Hello, dear. Good morning, and welcome back. Uh, you have started watching videos on machine learning. Uh, you see, we have so far studied various tools and techniques of machine learning, like linear regression, logistic regression, Bayesian theory and its application, course of dimensionality, and in this regard, we have learned PCA, that is principal component analysis, and linear discriminant analysis. Then we have support vector machine. Then we have studied k-nearest neighbor algorithm for classification. We have studied perceptron learning and backpropagation algorithm, neural network with unsupervised learning, decision tree and random forests. So all kind of tools and techniques of machine learning we have studied so far. And what is next? You see, once you are conversant with the tools and techniques of machine learning, the next logical steps will be to undertake some projects, semester project you can enroll, and then you can practice them, because these are just like, you see, an artist having color, having paintbrush and all the tools, but artist has to create, okay, and depending on the quality of the artist, same tools will produce different paintings. So it is very important to know this fact, and to know how to apply these techniques. By the way, up to support vector machine we have in our YouTube, but these KNN algorithm, perceptron learning, and then decision tree, random forest, these videos you have directly got to your account. But anyway, for my YouTube friends also, I will try to upload these videos when they are done. So far, so good. So, what is next in terms of learning new techniques and new tools? And these are all, of course, you know, the pure application. We have told you that test classification, spam filtering, sentiment analysis, and these are all creating lots of financial resource in the industry, fraud detection, especially in banking, recommendation system. That means you are exposed to some movie, and then whether you like it or not, this kind of things help, or any product, okay, based on your feedback, lot of corrective actions can be taken to improve the quality. Then multi-class prediction, then imparting intelligence to real-time system like robotics, autonomous car. They are fantastic applications are going on, okay, and stock market prediction. So all things you can do with the help of the tools which you have studied so far, but to a limited extent, which we are going to discuss next. Why the limited extent, and what is to be followed. You see, yes, you are right. The next semester course will be on deep learning. And why deep learning? See, the very important and interesting experiments were done by neurobiologists, and many pioneer scientists like Brigham Sood in MIT and many others actually deeply studied the plasticity, brain rewiring phenomena. What is this actually? You see, this is our cerebral cortex, and various parts are responsible for processing various sensory inputs. So, for example, visual cortex, actually, the nerves from the vision sensors, which is our eye, is connected in that part, this visual cortex. Okay, and that part earlier was supposed to be that actually that part only is processing the information related to visual sensor. Similarly, auditory cortex, where responsible or were thought to be the responsible for only processing auditory signals coming from a ear, for example. But some experiments showed that when in some cat the auditory cortex part were cut and it was connected to the visual cortex part, and the visual cortex part were connected to the auditory cortex. So this nerve cell actually nerve from eyes are connected to the auditory cortex, and then nerves that is the information coming from ears are connected to the visual cortex. Surprisingly, the cat, those portions were started processing signals accordingly. For example, visual cortex is now processing information from the auditory nerves, and the auditory cortex part is started actually processing visual sensors. So that created a sensation that's called famous brain rewiring experiment. That means that forced the scientists to think that there may be a more generic control in case of learning, in case of our brain, and that particular part is only doing a particular job. This kind of thing may not be true. And that inspired our computer scientists to think in a different way, the way we are trying to process our information so far. Okay, vaguely, of course, you see this cerebral cortex is our neural network we called. Okay, and processing power today is huge, and they are increasing thanks to the cloud computing. So many companies in a professional manner actually scaling up the computational facilities, and we can today think of creating a giant network, and different architectures are actually evolving to process information like the way our brain is processing. But the sensation of brain rewiring actually gave some new thought in the minds of computer scientists as well. You see, earlier in all these techniques and tools, the data were given, level data or sometimes unlevel data, okay, and in case of actually we were actually trying to create the important features which will be fed to this tool for classification. Okay, so the feature extraction part were handled basically by the scientist. Okay, and the way you can extract feature, people started getting newer and newer paper claiming that they have come out with a new feature, and then classification rate has improved like that. Okay, so those were the state of the art earlier in case of machine learning, but this experiment forced the computer scientist to think that maybe then we can also try to develop a big network architecture, computational architecture, and we have huge data today, and can we concentrate on developing smarter and smarter algorithm which will allow this infrastructure automatically to generate the important features which will be fed for classification. So this portion is actually, by the way, is known as convolution part, which is trying to understand the representation of the input image, and automatically is trying to create the feature, which earlier it was hand coded. So that's the revolution inspired from brain rewiring experiment. The idea here was that there must be some more generic control, not the specific portion of the cerebral cortex is responsible for processing specific sensory input, but more because unless that was the case, then the rewiring would not have been possible. Anyway, so that's a great idea. And then in 2001, there were lots of development in this area, and lots of revolutionary things were coming up. And it took another 9-10 years to realize this thing in the form of first AlexNet, the deep neural net. This is called incidentally the deep neural net, because the learning of the representation of the data or the feature is taking place automatically in this infrastructure, which is analogous to our brain, of course, vaguely inspired by our brain. But that started a remarkable, that started giving lots of results. And in this regard, I must tell you, this is the three well-known scientists, Yann LeCun, Geoffrey Hinton, and Yoshio Bengio. They got the Turing Award in 2018 due to their pioneering work in propagating the idea of deep learning and deep neural network. Specifically, Yann LeCun is very famous for first training neural network for hand digit recognition in 1980s. And almost in this similar time, this Geoffrey was actually propagating, both actually are propagating the idea of back propagation. And Yoshio Bengio is doing remarkable job in theoretical aspects and all. And his student Ian Goodfellow actually create quite a sensation in developing a generative model called GAN, Generative Adversarial Network. So these pioneering scientists, together with many others, created a vibrant field called deep learning, which you will be, I will be offering a course on next semester, and you will be able to get acquaintance with that field. Why deep learning? I gave you the reasons that one thing is that the network inspired from our brain is trying to learn itself, interacting with the environment. That's a big change. Okay, and it has now getting a lot of application, and it is increasing day by day. In self-driving car, for example, nowadays you can think of a smart car, okay, which can be driven autonomously without a driver and can deliver food and can take patient to the hospital, and many such applications are possible thanks to deep learning. Deep learning also creating new architectures for fraud detection in the news, because with the popularity of social media and all, many fraudulent news actually are spreaded by some vested interest people. They are creating a lot of sensation in the society, and it is now high time to actually come up with some fraud detection network which can actually distinguish between real news and fraudulent news. Then natural language processing, including machine translation, has taken a new shape under deep learning era. Now it is possible in real time language translation from text to text. For example, from language, text of one language to text of other language. Say you have text written in English, you can change it in Hindi or in Chinese or in other language momentarily, or from text to image. For example, in an image, some language is written and you do not know that language, so you can take the image with your mobile phone of that particular text embedded image, and then it can be, you can know what the meaning of it in your own language.
Then, of course, we have virtual assistants possibility now. You see, Google, this Amazon's Alex, Google Siri, not sorry, it is Apple Siri and Google Home. All this actually are actually are staying in at your home with you, and they can actually be trained with the data to learn your behavior, and they can suggest many things which are very, very important. For example, you can tell, "Hi Siri, what is today's weather?" And Siri can tell the weather. Not only that, it can also suggest that whether to take umbrella or not, etc., etc. Entertainment, yes, entertainment industry also are taking a new shape. For example, many companies are there, Netflix, Amazon Prime, this, that, okay. So they can stitch the content, deliver the content based on your personal liking and disliking, which they can understand. From data which they are taking from you. Then financial fraud detection, also another application. Endless applications are there with deep learning. You see, financial fraud detection in banking sector. For earlier, there used to be a lot of fraud with your credit card and all kind of loan sanctioning, all kind of thing, right? So now it's a possibility that since you have data of the customers, then huge data of the customer, you can train a giant neural network which can detect the possible fraud given a customer. In healthcare system also is taking a very is becoming a very vibrant area. You can predict nowadays many disease, for example, autism in children and many such disease, detecting development delay in children, all kind of disease. You can beforehand you can predict, and if it is predicted earlier, then sometimes diagnosis becomes much more easier. Then also drug personalization is another area which can revolutionize the way we use drug. You see, medicines, if we can personalize their effectiveness to the persons, you need a lot of data for that, and then the medicines which will be suitable for some person could be very useful. Also, personalization in any other area, for example, not only in healthcare, but in teleshopping, many companies are there, okay, and from where you buy products. And if they can, getting data from you, if they can develop a system which can know your personal liking, disliking, and accordingly they can modify next time they are offered to you. So these are enormous possibility in business. Then colorization of black and white images. You see, another fantastic. So can you imagine the earlier fantastic movies which we had in black and white, because technology was not there at that time? You can perfectly color them, okay, and that is possible today thanks to many generative models, which we will talk in our deep learning course. It is now possible. Now adding sounds to silent movies. Earlier movies were silent, and then you can perfectly add sound also. Okay, so it will be a virtually real movie which is now colored with added sound. Okay, and then demographic and election prediction. You see, very recently many elections happened in great democracies, and you could now, studying the demography of the and people, the voters, you can just predict, and prediction could be very accurate. Other thing is weather prediction is possible because now this kind of deep dreaming, you see what it is. This is another possibility shown by Google, some Google researcher, that you input some images or videos to the computer. Basically, you design neural net and then allow that architecture to hallucinate. And the way we actually are inputted some images, and then in the sleep we dream, which is nothing but hallucination of the some of the activities. So that is also possible now, and they can have application, future application in psychotherapy and other areas. Also, weather prediction now has taken a remarkable height. Earlier weather prediction, you see, we used to tell in our childhood that if weather forecast is today there will be rain in our area, then certainly it won't rain. But now today, how perfect the prediction is. So all these are possible because of tremendous development in the area of machine learning and deep learning. So the basic difference between machine learning and deep learning is, as I have told you, that availability of huge data and getting inspired by human brain, that we should not try to extract specific features in the data, but feed the data as it is in a network which we will focus on designing. And what we will focus on, another thing is how to design smart algorithm so that automatically the giant network, which is analogous to our brain, can extract important features. And then with those features, it can classify or it can do many other things. Okay, it can do cluster, classifying, all kind of things. So these are the story which we are going to learn next. Specifically, we learn models like convolutional neural network, then some sequence model like recurrent neural network, okay, recursive neural network, and then we will study also generative model like autoencoder, including variational autoencoder. Then we will also learn about reinforcement learning, including deep reinforcement learning. Okay, and why we will learn them now, you know, because today every individual is producing data using social media like WhatsApp or Twitter or Facebook. So there is no dearth of data. So sometimes data are labeled, which is very difficult to do, and sometimes data are unlabeled. So with the unlabeled data also, how to design architecture and model like variational autoencoder, how our network can learn the representation. So those are the things which are very exciting and which we are going to learn. But learning deep neural network is not possible without learning machine learning techniques, so which we have learned. So this is beautiful diagram by Andrew, which shows the performance of model with availability of data. So this is when the availability of data is not much, then a performance of our conventional machine learning tools and the other deep learning, medium neural network, small neural network, all neural network, deep neural network, their performance will be more or less same. Just concentrate in this zone. But as the data is increasing, then the neural net, especially deep neural net, is performing much better. So seeing this and knowing that although a lot of possibilities are there, with that possibilities, a lot of hypes are also there. Okay, so you must be careful that the requirement of your industry or of your problem you must know. For example, if I compare it with our vehicle, say this is like two-wheeler, this is like high-speed car, this is like train, this is like aeroplane. Okay, they consume different kind of energy, and if you know that, Then you can design your model accordingly. For example, I need to go to the railway station which is 5 kilometers away from my home. The question is whether you take a two-wheeler or bicycle, a bike, or a high-speed car or train or aircraft. I see nowadays, seeing the hype, many students from the 5th semester onwards, they are doing project on deep learning without knowing machine learning or without knowing anything about data science. So then the problem is you can very well design a aircraft for going from from your railway station, which is 5 kilometers away from your home. So be careful. Okay, so machine learning fast, because this is still the most revenue generating tools, okay, in the industry. And of course, in the next semester, we will expose you to the deep learning, and which can further revolutionize our society. Okay, so stay tuned and sign up for the course that will be in the next semester. Okay, so hope to see you soon. Till then, relax. Have a nice day. Stay safe. Bye bye.